So the alkanes are the simplest family of organic molecules, and we've got the first 5 here. We can only remember the general formula that we can use for all of these. You remember we have a CN plus 2, brilliant. So that is the general formula, but those are for linear alkanes. You can also have cyclic alkanes as well. So an alkane always has saturated bonds in it, always single bonds, fully saturated. The simplest ones we put on, so methane, CH4, we write like so. Ethane has got 2. So if I was doing a full displayed formula, I would have to write them like that. If I was only doing skeletal formula, methane would just be a dot, which doesn't really help. Ethane would be a line, which again isn't particularly useful. Propane, as soon as your pen touches the paper, that's 1, 2, 3, like so. Butane, 1, 2, 3, 4, and pentane, 1, 2, 3, 4, 5. Like so. So skeletal formulae are really useful for the alkanes, because writing full display formula gets pretty tedious. Obviously, if I was doing a structural, that would just be CH3, CH3. This one would be CH3, CH2, CH3, and so on. So you need to be pretty confident about writing these different formulae out. If we look at cycloalkanes, what they try and do is in the exam, they may give you a linear one, and you're quite happy with that, but what they're trying to do is mix it up a little bit and maybe give you a cyclic one. Behaves in exactly the same way, but...
Is it just 2 ends?
Yeah, for the cyclic one, so the simplest one would be that. That would be cyclopropane. And the formula, so it's going to be CH2, 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 like so. So that would be C3H6 or CnH2n. You've got to be careful, because that is a general formula, of course, for an alkene, a linear alkene. But that would be a cyclo. Do you think that molecule's likely to be happy? What are the bond angles? What have we just said these bond angles are? These are 109.5. What's going to be the bond angle between, what's the bond angle if that's an equilateral triangle? That's going to be 60 degrees. So it's going to be a very strained molecule. He's not going to be happy at all. Obviously, if you get slightly bigger, so you go to cyclobutane, you're looking more at 90 degrees, so slightly happier. But both of these would be unstable. They become more stable when you look for cyclopentane or cyclohexane is the most common one. Like so, they're generally happy. Like so. Okay. So, for the alkanes, you can have isomers. The first isomers kick in for C4H10. The one that we started off was just butane, which is 4 carbons in a row. But you have nicely made this guy here, which is CH3, CH3, and then a methyl group coming off there. So what would he be called?
2-methyl propane.
Ooh, he's keen.
Methyl propane. Do I need the 2?
No, it's not.
No, because it's in the middle.
Yeah, so it's methyl propane, so that's okay. So just quickly, let's revise boiling points, which should be familiar to you. So if I compare this series, methane, ethane, propane, butane, what's going to happen to my boiling points as I go down that route? They're going to increase in Y. What's happening? The size of the molecules are getting bigger, more electrons, and therefore increased van der Waals forces, more energy required to separate the molecules. What about these two guys here? These are isomers of C4H10. Which one is going to have a higher? Number 1 or number 2? Who's going to be higher?
No, one.
Number 1 will be higher, and the reason why,
Bigger surface area.
yeah, brilliant, bigger surface area. So if you think about what these molecules will look like, they can all line up. These are more like sausages, so they can all line up. These are more like balls, I suppose, like so. So they look like that. So they can all get quite close together. You've got a larger surface area, so more surface contact, so increased van der Waals. So always talk about increased van der Waals forces between the molecules, therefore a higher boiling point compared to these guys there. The more linear you've got, the higher the boiling point. The more branched isomers, the lower the boiling point will be. So always follow that routine.